we are going to have a look at Pythagoras' theorem. Pythagoras' theorem is a rule in maths that helps you find the length of a side in a right-angled triangle. A right-angled triangle has one angle that is exactly 90 degrees, like the corner of a piece of paper. So if you know the lengths of the two sides, you can find the third. And the formula is a squared plus b squared is equal to c squared, where a and b are the two shorter sides, and c is the longest side and called the hypotenuse, and the hypotenuse is opposite the right angle. So in simple terms, we square the lengths of the two shorter sides, meaning that we multiply each side by itself. That's how you square. And then you add those two answers together. Then you take the square root of that total and you have found the hypotenuse. So in this example, a triangle has sides A, which is equal to 3 units, and B, which is equal to 4 units. To find the hypotenuse, which is C, we say C squared is equal to 3 squared plus 4 squared. So 3 squared is equal to 9 and 4 squared is equal to 16. That, when we add it together, gives us the 25. So now we say C is equal to the square root of 25, and the square root of 25 is 5. So just a quick reminder, trigonometry is the study of triangles, especially right-angled triangles, and how their sides and angles are related. So how Pythagoras helps in trig is when you don't know all the side lengths of the right-angled triangle, but you want to find a missing side, or check your answer after using sine, cosine, or tangent. So how it connects to trig functions, sine, cosine, and tangent. Trigonometry uses the ratio of triangle sides. So sine is equal to opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is the opposite divided by the adjacent. So sometimes you might use sine or cosine to find a side, then use Pythagoras' theorem to find the third side. Looking at the combined use example at the bottom, we have been given a right-angled triangle. One angle, theta, is equal to 30. The hypotenuse, C, is equal to 10 units. So to find the opposite sides using trigonometry, we will say sine 30 degrees is equal to the opposite over 10, which translates to the opposite is equal to 10 multiplied by sine 30 degrees. When you get the answer of sine 30 degrees, it is 0,5. So we take the 10 multiplied by 0,5. So the opposite side is equal to 5 units. Now we use the Pythagorean theorem to find the adjacent side, which is B. So B squared is equal to 10 squared minus 5 squared. And when you get that, you find 100, because 10 squared is equal to 100, minus 5 squared, which is 25, which is equal to 75. That means B is the square root of 75. And when we find the square root of 75, it is not an equal to, it's an approximate value of 8,66. Just a couple of key tips. Only use Pythagoras' theorem in a right-angled triangle. You will use it to find missing sides, not angles. And we combine trig functions when working with angles or needing both sides and an angle.